So for problem number 9, we're trying to find 3 different pairs of parametric equations for the line segment that starts at the point 0, 0 and ends at the point 6, 6. So let's just draw what that looks like. So it's going to be 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. So our line is going to begin here, which is the point 0, 0, and it's going to end here, which is the point 6, 6, and it goes like so. And so we can see here that this is just a straight line with the slope of 1 and the y-intercept of 0. So the equation of this green line is y is equal to x, but x is restricted from 0 to 6. So x has the restriction that it's between 6 and 0. Okay, so once we're here, let's find the first pair of parametric equations. So the easiest case is just letting x be equal to t. And if y is equal to x and x is equal to t, it also means that y is equal to t. And since x is equal to t, it therefore means that t is also going to be restricted from 6 to 0. So what that means is that when t is equal to 0, we begin here. When t is equal to 1, we're at x is equal to 1, so this would be the point when t is equal to 1. When t is equal to 2, we're at x is equal to 2, and so on and so forth until t is equal to 6, which is x is equal to 6. So we can see that this is the direction that our parametric equation would take, where for every value of t, we're increasing one step on the x-axis. So now for our second equation, what we're going to do here is we're going to let t, the first value of t, which is 0, begin here, just like before. However, when t is equal to 1, instead of being at the point 1, 1, we're going to make it go to the point 2, 2. So this is t is equal to 0, that's t is equal to 1. T is equal to 2 would be the point 4, 4. So this would be t is equal to 2. And lastly, the point t is equal to 3 would be the point 6, 6. So t is equal to 3. So you can see that we're still going in the same direction, still going from the point 0, 0 to 6, 6. However, it's like we're going twice as fast. So instead of the t taking one step for every value that it grows, it's going to take 2 steps. So for that to happen, it means that x is going to be equal to 2t because t is double, and y, because x is equal to y is also for 2t. In this case now, our t is going to be between 3 and 0, because if I plug in t is equal to 3 into this equation here, we're going to have x is equal to 6, which is our final boundary here. And so for the third equation, we're going to make x is equal to, we're going to make t now go 3 times as fast. So this will be the point t is equal to 0. At t is equal to 1, we're going to be at the point 3, 3, so t is equal to 1. And at t is equal to 2, we're going to be at 6, 6. T is equal to 2. So still going the same direction, but now each step is really big. So x is going to be equal to 3t, and y is going to be equal to 3t as well. And in this case, t has to be now between 2 and 0, because if I plug in 2 in here, we're going to have x is equal to 3 times 2, so x is equal to 6. And that is the final boundary, right? Because x is contained between 0 and 6. So that is it for our 3 different parametric equations. They all describe the same behavior. However, what changes, if you can think of it in terms of speed, if you will, where the first one for every t just takes 1 step, the second one for every t takes 2 steps, and the third one for every t takes 3 steps. So that is it for problem number 9.